Hello everyone, so today we'll look at this question, one added distance. Okay, so given two strings s and t, return true if they are both one added distance apart, otherwise return false. The string s is said to be one distance apart from string t if you can insert exactly one character into s to get t, delete exactly one character from s to get t, or replace exactly one character of s with different character to get t. Okay, so there are two examples. First, S is AB. We want to convert it to ACB. Now, we look at the first one. A is the same. We'll go to the next one. B and C is not the same, right? So, but keep in mind that actually here we only have two letters, but here we have three letters. And by inserting exactly one character, which is C, in between A and B, we get T. So this is true. Okay, the second example, S and T, both of them are empty string. So to get from S to T, there is no operation needed. So it is not exactly one kind of operations, which means this is false. We cannot get T from S by only one step. Alright, so by looking at the example, it's actually we can do something. Let's just analyze and how should we do this question. So first of all, we notice that the input is two strings, s and t. So we want to convert s to t, right? Or s to t. Or it's actually the same. It's reversible, or t to s, because insert, delete, and replace are the three essential operations that we need, and this operation that we actually need for most of the questions when we doing kind of changing from one string to another, because there is also a dynamic programming problem that we can look at later, which has some idea that are kind of similar, but it's not really applicable to this question. So, but anyways, so first input is s and t, and both of them are string type. All right. So what about the edge cases, right? So before we really go into the algorithm, we should think about what kind of things that we should not consider or we should exclude. So in this case, since only exactly one operation is considered, so it's not 2, it's not 0, it's not 3. So that means the length of these two strings, or let's say the difference of the length of these two strings should be like smaller than 2. It cannot be 2, right? If it's 2, then we cannot do we cannot convert from S to T in only one operations. One edit does not allow that. We should do that in at least two edits. All right. So let's look into the algorithms, right? So what are the scenarios for in these questions? First scenario, if the length of s is equal to the length, just like equals to length of t. In this case, we'll notice that the replacement is the only operation that we can do to change from s to t. So we can only consider replacement. All right. Another case, if the length of s is smaller than the length of t, then what we can do here is we can do insert. Okay. So what about deletion? Deletion would be if the length of s is larger than length of t. We will do delete. And in this case, actually, we can do something. We can actually do some, preparations that we don't really need to consider, both of them in two separate conditions. We can actually make the smaller string into this first position and consider it as s, and make the longer string considered as t. All right, but we'll do that before this step. Okay, so we'll have these operations, and we can compare the remaining strings. If they are the same, then in this case, we'll say true because it will be converted successfully within one edit. If the rest of the strings are not comparable, which means they are not the same, then it's likely that it's going to be a false. Okay, so, and also we need to really handle the case when both strings are exactly the same. So let's say in this case, if two strings are exactly the same, then we have to think. Are they? Are they only do they only have the similar length, or is it like they are? Is it like they are exactly the same? So if they're exactly the same, then it's a false, because there is no operations needed to convert from one to another. Okay, so but without any further ado, let's just go to these algorithms. All right. So first of all, we need to know the length, right? So let's make it m is equal to the length of string, and n is equal to the length of t. All right. So if m, because we want to do some pre-processing, so if m is larger than n, then we'll do return self dot is one added distance, and then do we'll just make them in the we'll just switch their positions in this parameter. Okay, so now we have so now the input is going to be this. The first one is always going to be smaller than s, and because we're seeing that actually it's calling itself, so m and n is going to be updated automatically. So m is always going to be smaller or equal to n. Okay, so let's go to and also we need to handle these edge case. How to handle this edge case? So if n minus m is larger than 1, right? Then we're going to return false. There is no need to do further operations. Okay, so here is the interesting part, which is the core algorithm. We'll make a 2 pointers. So both pointers are going from leftmost index of s and t. Okay, so for I in range what? In range the m, because if we're doing the in range of n, there's a potential issue of out of bounds, right? So if for I in range of n, if s at position I is not equal to t at position I, which means we firstly find a difference, okay? So there are also two scenarios, right? So if m is equal to n, okay, so if the length is the same, then we can only consider replacement. So what we want to compare is the remaining part. So return s at position I plus 1 till I plus 1 till the last one, and also t at position I plus 1 till the end. So if these two remaining parts are the same, then we only need to do one operations to replace this character in this index of I, then it's gonna work, right? So that's for if both of them are the same. I mean have the same length. Okay, so else if they're not having the same length, so which means m is smaller than n. Okay, so as the length of s is smaller than the length of n. Okay, so what we want to do here is we want to consider a insertion case, right? So we want to return s at position of I till the end is equal to t at position of I plus 1 till the end, right? So why this case, right? So as I said, here we are considering a insertion. So which means, okay, so which means if we insert a new, like a new letters at position I, then we'll just having the same remaining, have the same remaining string. So if the remaining string are the same, okay, so we'll know that it's actually gonna work, and a insertion is totally enough to deal with these scenarios. All right. Now let's think about the case when the previous m letters are the same. Okay. So what if, let's say, there are two strings, A, B, C, right? Okay, A, B, C, and another one is A, B, C, D. Okay, so the lengths of them are different. So we're, let's just go to this loop. Let's think about it. Let's just like dry run. Okay, first three, same, no problem. The last one, okay, go to last index. C is still same equal to C, right? It's not gonna go to this condition. All right, so the loop ends and nothing finds, right? So we need to deal with this scenario because this for loop does not deal with it. So how to deal with it? In this case, we'll just compare if the length of this character is exactly one shorter than the length of this character, which means if that's the case, then we can simply add a letter after C, and we'll just get the exactly the same two strings. Okay, so return, because as we say here, we already processed the length, right? So m is always going to be smaller, so m plus 1 is equal to n. All right, so let's think about the time complexity, okay? So the time complexity, what's the time complexity and the space complexity? First of all, the runtime here, we notice there's a for loop going from the length of m, right? So it's going to be a big O of n. And inside, there's no nested loop, and each one is just and it's just a a string comparison for each index. So it's compare the letters at the same position of S and T. So it is gonna be a big O of n, right? All right. So and for the space complexity, it's gonna be a big O of n as well, because this chopping in Python is a big O of n, because it creates new strings for every single iterations inside the Python logistic. Okay, let's run the code. Does that work? Okay, yeah, accept it and submit. Alright, that's good. Thank you so much.